Hello Year 10, it's Miss Bailey here. Please have your worksheet ready to be filling in as we go through this video. For your do now, you've got 3 retrieval questions to have a go at. Please pause the video whilst you do this. Okay, so for the first question, our answer is acid plus metal goes to salt plus hydrogen. What acid would be needed to form copper sulfate? So in order to get sulfates, we need to be using sulfuric acid, which is H2SO4. So that is our sulfate ion there, SO4. And because hydrogen has a +1 charge, we can work out that sulfate has a 2- charge. And then question 3, why is the formula for ammonium carbonate NH4 2CO3 and not NH4CO3? And so the answer there comes down to our ammonium having a +1 charge and our carbonate having a 2- charge. So because we've got a 1+ and a 2- charge, we need more of the NH4+ in order to make sure that we have overall a neutral charge, and therefore we're going to need 2 NH4s so that we have a 2+ and a 2- to overall make it equal to 0. So by having brackets around the NH4, that 2 is telling us that we have 2 lots of everything within those brackets, so 2 of those NH4+ ions, and then we have our carbonate, which is a 2-, and overall that becomes overall neutral, whereas this would not give us an overall neutral charge. So what we're going to be looking at today is neutralisation. Now I've just been using the term neutral when talking about charges, but we also use neutral when we're talking about acids and alkalis. So when we're talking about neutralising something, we are making it neutral. So in terms of our pH, we would be moving it towards that neutral point on our pH scale of 7. So what you can see here is that if we start off with an acid, as we add alkali, we move up the pH scale towards our neutral point at 7. Whereas if we start off with an alkali and we add acid, we move down the pH scale to our point of 7. So acids can be used to neutralise alkalis, and alkalis can be used to neutralise acids. So pause the video whilst you fill in those gaps. So acids and alkalis can react to form salt and water. So here we've got our acid reacting with our alkali. So remember, our alkalis have the hydroxide ion, and they react together to form our salt and our water. So what has actually happened here is our hydroxide ion and our hydrogen ion have reacted to make water. Now our metal and our non-metal X here, they remain ionic and they form an ionic bond together, but actually they haven't changed from this reaction. And so an ionic equation to represent this, so showing only the substances which have changed, is H+ and OH-, and they are aqueous because we've dissolved our acid and alkali in water, remember. And we then form H2O, and water of course being our pure liquid that we're doing this experiment in. So on neutralisation, our acid and our alkali reacting to make our salt and our water, but for our ionic equation we're looking at the hydrogen ions plus our hydroxide ions making water. So you have a couple of equations to be filling in on your worksheet, so please pause the video whilst you do that. So this is an example of a neutralisation reaction. So hydrochloric acid plus sodium hydroxide forms sodium chloride and water. So we're just going to take a quick look at how we get to the name of sodium chloride, but it might already be clear from the colour coding of this diagram. So with our sodium, this has come from our alkali because that's what contains our metal ion. And then our chloride, as we have looked at previously for other salts that we've made from just metal and acid reactions, that comes from the type of acid that we've used. So because it's hydrochloric acid, that tells us that it's the chloride. Could you pause the video whilst you label your diagram? So as we saw at the start, I tried to show this idea of neutralisation using colours. So the colours there were representing the universal indicator. Now, indicators can be used to identify our end point of neutralisation, so the point at which pH is equal to 7. And we know that at that point of neutralisation, we must have the same amount of H+ ions as the amount of OH- ions in order for that pH to be 7. So at our neutral solution, so at a pH of 7, that is the point at which our amount of H+ is equivalent to the amount of OH-. So you can see here it's a level balance and therefore equal amounts. Please could you answer the 2 questions about this on your worksheet? So what I'd like you to have a go at now is completing this table to show what our beaker, so this one, which becomes this one, and this one, at each stage of the experiment. So at the start, we've only got hydrochloric acid. We haven't added the sodium hydroxide solution in yet, but we do have some of it in our midway point, and we've added more of it by the end point. So remember that our end point is when our pH is equal to 7. So think about which of these substances are going to be our neutral products that are produced in this reaction. What do we have at the start? And what do we have midway through? So thinking about the fact that sodium hydroxide solution, as it's added, is going to react with the hydrochloric acid. So think about what's going to be present in midway. And then the second part is to describe how the pH changes during the reaction. So they've told us that the pH of hydrochloric acid is 1, and so I'd like you to state what the pH would be at the end point and how it changes during that reaction. So increasing or decreasing. Don't need you to specify a pH at the midway point because that is going to vary between those 2 pHs. So pause the video whilst you have a go at this. So we looked at the pH scale a couple of lessons ago, and we saw some common uses of, and we saw some common acids and alkalis. So this is hopefully familiar to you, where we've got our water at 7 in the middle, we've got coffee at 5, orange juice at 3, lemon juice at 2. We talked about baking soda being about 8 or 9, and then we've got some oven cleaner, washing soda, soap, so some cleaning products there towards that higher end of the pH scale. So we're going to take a look at some uses of neutralisation. So you won't need to write anything down for these next few slides, but there will be some questions afterwards. So the first thing I'd like you to consider, so if you have been stung by a bee, which substance would you use to neutralise the sting and stop it from hurting? So bee stings being a pH of 3 and therefore acidic. Out of those 4 options, which would you choose? So the answer is bicarbonate of soda because it is an alkali and therefore would neutralise that bee sting. However, wasp stings are actually alkaline, so what are you going to use instead this time? So this time we should use black coffee, so that has a pH of 5 and can therefore be used to neutralise it. You might have put lemon juice, However, lemon juice being of a higher pH, that might send it too far to the acidic side. When you have indigestion, it's because we have too much acid being produced in our stomach. Hydrochloric acid in the stomach is around a pH of 1, so which of those 4 options should we use? So this is antacids, it was the only alkali in those options. Ant being like anti, so it's against acid is the name of this. Do you think that toothpaste is an acid or an alkali? Why? So I don't need you to write this answer, I just want you to have a think. So if you remember the pH scale from a couple slides back, we said how lemon juice and orange juice and coffee, they were all acidic. So during the day, we actually eat and drink a lot of food and drink that is acidic. And this acid can build up in our mouth and on our teeth and therefore cause tooth decay. So by having a toothpaste, which is an alkali, that's going to neutralise the acid that's on our teeth and therefore prevent our decay. So here are the 4 questions for you to have a go at on your worksheet. Pause the video whilst you have a go at these. And what I'd now like you to do is have a go at practicing the word, symbol and ionic equations in each of these activities. So pause the video whilst you have a go at those. Thank you all for watching and see you next time.